right, so today we're going to review trigonometric functions. So this is like one of those built-in review days so that next class we can learn how to take the derivatives of trigonometric functions. So do you guys remember how to convert between degrees and radians?
Absolutely.
Yeah, how?
Degrees, you do pi over 180.
Yeah.
Radians, 180 over pi.
Yes, so if you have radians, multiply by 180 over pi to get degrees. If you have degrees, you multiply by pi over 180. So the conversion factor is that 180 degrees is equal to pi radians. And you can either remember that conversion factor, or you can always set up a proportion, right? If I wanted to know how many radians 34 degrees was, I could say, well, 34 is to 180 as how many is to pi, right? Just set up a proportion and you solve it. 180 and pi are the equivalent angle measures. All right, so one really important key to success with trigonometry is the unit circle. So this should be like your best friend from pre-calculus. So I'm going to fill in the first quadrant with you, and then the rest of it gets filled in via symmetry. So you don't have to, you really just have to memorize 3 points and 3 angle measures, and the rest is symmetry. So we always start measuring in the unit circle on the positive x-axis. We call that 0 degrees, 0 radians. And what are the coordinates right here in the unit circle? Close. 1, 0. All right, and if we go 90 degrees, we land up here. This is 90 degrees. How many radians is 90 degrees? Pi over 2. Pi over 2. If you didn't know that, you would set up a quick proportion. 90 over 180 equals what over pi? And you solve and you get pi over 2. All right, and what are the coordinates at this point at 90 degrees on the unit circle? 0, 1. All right, and then the 3 points in between, we determine by using 30, 60, 90 triangles. But mostly, once we had derived that in pre-calc, you were just expected to know it, right? You don't rederive it every time. So this is 30 degrees. And in radians, that's pi over 6. And the coordinates of this point, root 3 over 2, 1/2. Good. And then the next line, that's 45 degrees. And it's pi over 4 radians. And the coordinates of that point, square root of 2 over 2, square root of 2 over 2. Some people might have learned that as 1 over root 2. They're equivalent, same thing. Okay, then the next one is 60 degrees, or pi over 3 radians, and you reverse the coordinates from the 30-degree angle. So this is 1/2 root 3 over 2. And then the rest you can fill in, the angles you can fill in by counting, right? So this first angle is pi over 6, and then you can just count by pi over 6. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces to pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6, which reduces to pi. So you can count by pi over 6s, and then you can count by pi over 4s. This is 1 pi over 4, 2 pi over 4, reduces to pi over 2, 3 pi over 4, 4 pi over 4, etc. And then you fill in the rest with symmetry. So all the points in the first quadrant, you go to get to them, you go right and then up. So points in the second quadrant, you go left and then up. So these are negative, positive. And then the third quadrant, negative, negative. Fourth quadrant, positive, negative. All right, so I'm going to let you fill in the rest of that on your own at some point. Probably for your test, it'd be a really good idea to have a unit circle on your note sheet. It's just a handy thing to have. Okay. On the unit circle, how do we define the sine of an angle? Y. It's the y coordinate. And the cosine of the angle is the x coordinate. Tangent of the angle, y over x. Cosecant,
It's 1 over sine.
1 over sine or 1 over y. Yep. Secant, 1 over x. And cotangent is the reciprocal of tangent, so that's x over y. All right, but what if we want to define the trig functions in a right triangle? What's the sine of t then? Opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. And then cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent, respectively. So these are all, just flip the fractions. Hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. So we're going through this pretty quickly. Hopefully it's review. These are pictures of the graphs of the 6 trig functions. You should be most familiar with these top 3. The bottom 3, they come up every now and again, but you don't really need to know exactly what they look like off the top of your head all the time. But the top 3 are important: sine of x, cosine of x, and tangent of x. So you notice sine starts at its midline, right? Its y-intercept is 0, and then it goes up from there. Cosine starts at its maximum and goes down. So when you're using sine and cosine to model stuff, that's an important thing to remember. All right, so here are some facts about trig functions that have the form a times the sine or the cosine of b times x minus c plus d. So what can you remember? What all those letters mean? A is the amplitude. It's actually the absolute value of a, because it's just measures a distance from the middle to the top or the middle to the bottom. All right, what does b tell us about? The period, yeah. So the period is calculated as 2 pi divided by b. And if you know the period and you need to know b, you could just solve for it. Right? B would be 2 pi divided by the period. What does c tell you? Horizontal shift. Now, if there's a minus sign there, which way do we shift? Right. And if there's a negative sign, you shift left. Good. And what does d tell you? Vertical shift, up or down. I like to call it the midline, the place where you move that middle line. You actually move everything, but it's most handy to move the midline first. Midline is the line y equals d. You can also think of it as the vertical shift. All right, so now that we have that, we'll do this modeling problem together, and then I'm going to let you work on some stuff. So we have a rabbit population that varies sinusoidally between 3,000 and 5,000 rabbits. So it goes up, it goes down, it goes up, it goes down. That's what sinusoidally means. And the last 2 times the population reached 5,000 were in 1990 and 2000. So we want to model the population of rabbits as a function of t, the number of years since 2000. So for me, I start by drawing a graph of what's happening. Then I try to write the formula. So I'm going to put some axes on here. We've got time, and we're measuring since 2000. So 0 is 2000. And I have data for 1990. So I need a -10, and I need a 10 for, I guess I don't need that. And then I'll put in a couple more here. And then I'm varying between 5,000 and 3,000 rabbits. All right, so in 1990, I had 5,000, and in 2000, 5,000. I really did a very poor job setting up these axes. Maybe I'll redraw it. There we go. So 1990, 5,000, 2000, 5,000. So if it's varying sinusoidally and it hits a max at 1990 and 2000, halfway between there, it should have hit a low. So here at -5, we should have a minimum value of 3,000. And what happens halfway between a high and a low when you're doing a midpoint, when you're varying sinusoidally? Halfway between 3,000 and 5,000 is 4,000. So halfway between 5 and 10 is 7.5. I'm not going to label it. Just know that it's 7.5. And 2.5. So there is one period of the rabbit population graphed from -10 to 0. And then I could just copy it to go from 0 to 10, right? Because it just is going to repeat every 10 years. So I can put a max here at 5,000, min here at 3,000. Halfway in between, it hits the midline. So the y-intercept, is that at the midline, at a max, or at a min, or neither? It's at a max. So which trig function naturally starts at its maximum? Cosine. Okay, so I want to use cosine to model this. So I'm starting to write out the formula here. What's the amplitude of that function? 1,000. That's the distance from the midline, which maybe I'll sketch in here. Midline is this middle point. So the amplitude is the distance from the midline to the max or the midline to the min, 1,000. Okay, and then what is the period of this function? 10 years. So if my period is 2 pi over b, and the period is 10, what's b? Pi over 5. 2 pi over 10 or pi over 5. So I'll put in the b right here, pi over 5. Do I have any shifting moving on, horizontal shifting? Nope, because I started right at a max, which is where cosine naturally starts. I don't have to shift. And where's my midline? 4,000. So there is my model that tells me the number of rabbits since the year 2000. Everybody remember that? How that works? Okay. All right, so during what year and month will the rabbit population next be 4,500? So how do I use that 4,500 to figure out what 4,500 is y? Yeah, so we're using, oh, I should have used a t. That's okay. So x is representing time, y is representing the rabbit population. So I just want to solve this equation, 4,500 equals 1,000 times the cosine of pi over 5x plus 4,000. I just heard a bunch of calculators being opened, which is great. We're going to solve it with the calculator, but first I'm going to do it algebraically. So when you're solving a trig equation, first goal is to what? Isolate it. Isolate the cosine. So I'm going to subtract 4,000 from both sides and divide both sides by 1,000. So I get 1/2 is equal to the cosine of pi over 5x. Inverse cosine, or mentally picture a unit circle, right? Which is the same thing as taking the inverse cosine. So if I'm looking at the unit circle, I'm looking for a place where the cosine is 1/2. Let's go back to the unit circle here. Anybody see an x coordinate of 1/2 on the unit circle? Pi over 3. Anywhere else going to have an x coordinate of positive 1/2? Yeah, in the fourth quadrant down here. Yeah, it would be negative pi over 3 or 300 degrees. Yeah, yeah. So what is it? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 6 or 5 pi over 3. So pi over 3 and 5 pi over 3 both have an x coordinate of 1/2. That means that the cosine is 1/2 at those two angles, pi over 3 and 5 pi over 3. So that means that this angle, pi over 5x, is equal to pi over 3 or 5 pi over 3, or infinitely many other angles, because I could just keep going around the circle and saying, oh, I hit a half, I hit a half, I hit a half, I hit a half, right? But I'll just use these two because it just asked for when will it next be 4,500. So just the one next time. It's going to hit 4,500 infinitely many times because it just keeps going up and down and up and down. So if I want to know when it will next hit, I really only need the next angle. I do, yeah. Yeah. This is my angle that I'm taking the cosine of, pi over 5x. So this angle, this thing that I'm taking the cosine of is a half. So that means that that angle has to be pi over 3. Okay. So when I solve for x, multiply by 5 over pi, and I get 5/3. What does that represent? 5/3 what? Years. Yeah. Or 1 2/3 years, which is 2001. What month? August. So 2/3, 1/3 of a year is 4 months. So 2/3 is 8 months, which is the month of August. Yep. Right. Yes. Yes. I wasn't done yet. All right. So let's just quickly show how this solution would happen graphically. So I've got my graphing calculator. You know what? I'm going to use GeoGebra. It's way better. Okay, so my function is f of x equals 1,000 times the cosine of pi x over 5 plus 4,000. Make sure that that got entered the way I wanted it to. Yeah, that's the same thing as pi over 5 times x. So yeah, that works. Hide that. And then I can't see it because I got to change the window here. And I want the axes on the edges, not, how do I do this? There we go. All right, so I got to be able to see 3,000 to 4,000 to 5,000, I mean. Huh. Yeah, but I only want to zoom in one direction, the Y direction. Yeah, this seems like really tedious, yeah. I guess I could do that, huh? Okay, so X min, let's go negative 20 to 20, and Y, we need to go from, let's say, 5,500. There we go. Okay, so there's my sinusoidal function. Looks just the way I want it to, right? It hits 5,000 at 0. Wait, that should be a max. Oh, right, there we go. Oh, because that's not my y-axis, that's just the, oh, I don't like that. I know. All right, let's put 0 there. Perfect, okay. All right, now I'm going to graph the line y equals 4,500. And so this point right here is the next time that my rabbit population hits 4,500. So I just do intersect f of x, comma a, and it gives me the coordinates of that point. Oh, I want the next one. Should use the graphing calculator. Well, it's symmetric. That's negative 1 2/3. So over here would be positive 1 2/3. So there we go. Okay, so the question is, if you want to rewrite this equation using a horizontal shift, so basically you can't use cosine, right? Or, I mean, you could shift it by the period, right? You could shift it by 10 years and it would be an equivalent equation. So if you wanted to shift it,
You want to find it at 2 years. How you want to find it at 2 years?
no, like, so what would you use it for? Basically, sometimes the book asks you rewrite this equation using sine function. And so then you would have to use the sine function with a shift. Yeah, so you'd have to shift it over by a quarter of the period because that sine would start at its, or here, depending. Shift it to here or to here, like pull that back to the axis. And this, if you use this as your starting point, it would be negative sine. If you use this as your starting point, you'd use sine, and you would just have to shift by either 2.5 years or 7.5 years.